Humans may one day live on Mars. Yes, that's right. Just as we are talking right now, a car-sized rover named Perseverance is roaming the Martian surface. So, why did we send a rover to Mars? Its mission is a part of a larger plan to prepare Mars for a possible human settlement. But the problem is, how do we go from sending robots to finally human settlers? Hi, I am Aggie, and this is the video about Mars. We will talk about what it is like to live there and break down the steps to see what it would take to call Mars our new home. As we see from the past examples here on Earth, it is natural for a civilization to explore and expand its territory, be it for acquiring more resources, to showcase power, or just out of curiosity. But beyond just curiosity, expanding to Mars may one day be more of a necessity than a choice. As Earth faces increasing challenges like global warming, climate change, and overpopulation. These are not distant future problems, they are happening now. And as we deplete resources and strain the planet's ability to support us, Mars starts to look less like a distant dream and more like a necessary backup plan. Surprisingly, the red planet shares some key similarities with our home world. Like, for instance, Mars has a day length of 24.6 hours, nearly identical to Earth's 23.9-hour day. It also experiences distinct seasons, although they last longer due to its axial tilt. Mars is about half the diameter of Earth. But here is an interesting fact. Mars has a surface area nearly equivalent to Earth's dry land. It's just half the size of Earth, but still gives us enough land to stretch our legs. So, even though Mars feels distant and alien, it is more familiar than you would expect. But before we pack our bags, let's see what it really takes to transform the red planet into our new home. The first challenge is transportation. You cannot just hop on a rocket and blast your way off to the red planet. Take a look at this video. Did you notice something? Yes, it is the distance between the planets. Mars usually remains very far from Earth. To reduce travel time and fuel requirements, we have to wait for a specific window where the planets are closer. This window, which is the best time to launch yourself, comes once every 26 months. Okay, this is not a big deal. You wait and launch yourself at the right time. What is next then? If you look not so closely at the pictures of Mars, you will see the next problem. Yeah, it definitely looks like a desert. While it may seem like a barren wasteland now, its past tells a different story. Imagine standing on the banks of a Martian river. This sounds so impossible, right? However, new research suggests this scene might have been a reality for hundreds of millions of years longer than we thought. Okay, so how does this change our understanding of Mars as a potential second home? Glad you asked. The red planet is dotted with ancient river valley networks, deltas, and lake beds. These geological features hint about a world that once had flowing water on its surface, much like Earth today. You see, this is not just an interesting fact. It is a crucial piece of the puzzle in determining whether Mars could have supported life in the past and whether it might be able to support human life in the future. But how do we know all of this?
How?
Scientists have piecing together Mars's history through careful analysis of its surface features and geological composition. The presence of this water-formed landscape suggests that Mars once had a thicker atmosphere and a warmer climate, allowing liquid water to exist on its surface for extended periods. In fact, recent analyses have revealed something even more exciting. Mars may have had a stable, Earth-like climate for up to 500 million years longer than previously thought. This extended period of potential habitability significantly increases the window during which the life could have potentially developed on the red planet. In short, Mars was once warmer, wetter, and possibly habitable. Now let's talk about what happened. Fast forward to present-day Mars. The planet we see today is vastly different from its ancient self. Mars now has a thin atmosphere, primarily composed of carbon dioxide, which is less than 1% as dense as Earth's atmosphere. This thin blanket of gas exposes the surface to high levels of radiation, making it inhospitable for life as we know it. Water on Mars today exists mainly as ice in the polar regions and as vapor in the thin atmosphere. The current atmospheric conditions are too thin for liquid water to persist on surface for long periods. The average temperature on Mars is extremely cold. This water and temperature situation may seem like a deal breaker, but despite these harsh conditions, Mars still holds promise. The evidence of ancient lakes and rivers indicate that Mars once had the physical, chemical, and energetic ingredients necessary to support life during its early stages. The presence of valley networks on Mars, which are formed by flowing water, suggests that planet once had conditions suitable for life, with significant rainfall near the equator. These findings are crucial because they indicate that Mars was not always cold, dry, and barren planet we see today. If Mars was able to sustain Earth-like conditions for such extended period, it might still contain subsurface water or even microbial life. Additionally, the resources left behind from this wetter era could be invaluable for future human mission to Mars. Okay, so ancient resources of Mars look promising, but tapping into them requires overcoming extreme conditions. Enter NASA and SpaceX, unlikely allies in the mission to make the red planet our second home. Their groundbreaking work is laying the foundation for human survival in one of the most inhospitable environments imaginable. NASA's Artemis program and SpaceX Starship are the forefront of this ultimate Mars goal. While Artemis aims to establish a sustainable human presence on the Moon, it is not just limited to lunar exploration. The mission to the Moon serves as a crucial stepping stone, allowing us to test technologies and develop strategies for the ultimate goal, the Mars colonization.
With each successful mission, Artemis ushers in the next wave of men and women to explore our Moon and prove that together we are ready to go beyond.
SpaceX, on the other hand, is developing the Starship system, a fully reusable spacecraft designed to transport large payloads and eventually send humans to Mars. This ambitious project represents a significant leap in our ability to reach the red planet. NASA and SpaceX's collaboration is evidence of the shared commitment for driving space research. But before human boots touch Martian soil, robotic explorers are paving the way. The Mars 2020 Perseverance rover is currently roaming around the planet's surface, searching for signs of ancient life and collecting samples for future return to Earth. This mission is providing invaluable data about Mars's habitability and potential resources.
This is the sound of wind on Mars. For the first time, we can hear the wind blowing across the surface of Mars to go along with all of the images that we've acquired of dust devils and dust storms over the many years of exploration on the surface.
One of the most exciting technologies being tested on Mars is MOXIE, an abbreviation to Mars Oxygen In Situ Resource Utilization Experiment.
Now, what is MOXIE? It's a prototype of a small engine that will produce oxygen out of thin air. Thin air on Mars means carbon dioxide. We need this, of course, so that future astronauts will be able to breathe.
This innovative device is designed to convert carbon dioxide, which makes up about 96% of the Martian atmosphere, into oxygen. If successful, MOXIE could be a game changer for future Mars missions, providing a sustainable source of breathable air for astronauts. And that's just one of the innovations in the works. Wait until you hear what's next. Water is one of the crucial resources for human survival. The rover is also examining the presence of water.
There's so much water on Mars in the form of ice that if all of it were to melt at once, the entire planet would be 1,000 feet deep in water.
We already have the technology to just about perfectly recycle it if we need to.
They're going to take that water, clean it up, get all the sewage out of it, and treat it with chemicals and other things, and you'll be drinking it.
It's cleaner and safer than your tap water when it's done.
It's not just because we're going to melt it and brush our teeth with it, but also because water is made up of hydrogen and oxygen, and those are the two components of rocket fuel. And so you break apart the hydrogen and the oxygen, and now you've got this fuel source, and that can help sustain you and keep you in this place.
That means we kind of have sorted out oxygen and water problem. But the harsh Martian environment presents numerous challenges, from extreme temperatures to high radiation levels. However, researchers are developing creative solutions. Take a look at this material. It is called Silica aerosil. Remember this material, we will talk about this later. It will be important. Laura Kerber is a research scientist at NASA Jet Propulsion Laboratory. She emphasizes the potential for human habitation on Mars.
And beyond the Earth, we've found over 2,000 planets rotating around other stars. So you talk about the world, like that's not the world. The world is out there. The world is beyond. The universe is out there. And Mars is our first step that we can take into that universe.
This statement underscores the significance of our current efforts to understand and prepare for the life on the red planet. The technologies and mission currently underway are transforming our approach to Mars exploration. We are no longer just observing from a distance, but we are actively preparing for a future where humans could live and work on Mars. Each successful experiment, each new discovery brings us one step closer to turning this science fiction dream into reality. As we dream of Martian cities, we are overlooking one crucial detail. Mars does not want us there. The red planet's harsh reality could transform future settlers in ways we have never expected. What if I told you that living on Mars might change our bodies in ways we have never experienced before? Let's start with the gravity. Mars has about 38% of Earth's gravity, which might sound fun at first. Imagine bouncing around like you are on a trampoline all day. But this reduced gravity can lead to serious health issues over time. Our bodies have evolved for Earth's gravity. This may lead us to experience muscle atrophy and bone density loss. Imagine your muscles weakening just from walking around and your bones losing strength simply because gravity is so much lower. Living there could fundamentally change how we as humans look and feel. The Martian environment presents other challenges too. The planet's thin atmosphere is 96% carbon dioxide. This cannot protect us from cosmic and solar radiation like Earth's atmosphere does. This exposure could weaken our immune systems, making us more susceptible to diseases. And let's not forget about the temperature, which averages around -62 degrees Celsius or -80 degrees Fahrenheit. Mars is essentially a deep freezer. The thin atmosphere means heat escapes easily, making survival without proper protection nearly impossible. What do you think? Could you handle living in a place where temperature drops to -80 degrees Fahrenheit? Let me know in the comments. But wait, there is more. Mars likes to throw planet-wide temper tantrums in form of global dust storms.
Dust storms on Mars can be absolutely enormous. They can be 20 to 30 kilometers high. And in fact, the dust can get charged. And in the case of these really tall dust storms, lightning can strike.
These dust storms are huge. They can cover the entire planet, and they can last for months.
For potential Martian settlers relying on solar power, this could be a major problem. Imagine your entire energy grid shutting down because the planet decided to kick up some dust. So, how do we overcome these challenges? One idea is to use Martian soil for construction. We could build habitats that shield us from radiation and insulate us from extreme cold. Another option is to go underground, creating subterranean living spaces that offer natural protection from the harsh surface conditions. Power is another crucial factor. A combination of solar and nuclear power might provide the most reliable energy for Mars colonization. This dual approach could ensure we have power even during those pesky global dust storms. But here is where it gets really interesting. Researchers are exploring the use of silica aerosol to create localized habitable environments on Mars.
Because it's translucent, light can still pass through it, allowing for photosynthesis to happen underneath. But because of what it's made of and how it's structured, it makes an incredible insulator. It's 39 times more effective than fiberglass. In fact, aerogel has already been used for this purpose on Mars. It's helped keep components warm on every rover we've ever sent to the Red Planet. Better still, the material also turns away UV rays that cause sunburns and damage DNA.
This material could mimic Earth's greenhouse effect, which potentially raise temperatures in specific areas above the melting point of water. Robin Wordsworth, a researcher working in this concept, stated, "This regional approach to making Mars habitable is much more achievable than global atmospheric modification." Imagine a Martian greenhouse where 2 to 3 cm thick shield of silica aerosol creates a warm, Earth-like environment. It's like creating little pockets of Earth on the Martian surface. Of course, we cannot forget about the need for pressurized habitats. Mars's thin atmosphere means we cannot just walk around in t-shirt and jeans. We will need enclosed living spaces that maintain Earth-like pressure and oxygen levels. This could be built using Martian soil or created underground for added protection. As we consider Mars as our potential next home, we must grapple with the ethical implications of colonization. If we find life on Mars, even if it's just microbial, do we have the right to interfere? Should we terraform another planet when we are struggling to preserve Earth? The discovery of microbial life on Mars would raise complex questions about planetary protection and our responsibility to preserve extraterrestrial ecosystems. The journey from Mars's Earth-like past to its current inhospitable state and our ongoing efforts to explore and potentially colonize it reflects humanity's enduring quest to understand our place in the cosmos. As we continue to unravel Mars's secret, we edge closer to the possibility of becoming a multiplanetary species. The Red Planet challenges us to reimagine our future and pushes the boundaries of human ingenuity and exploration. Are you curious about the dangers of space? Check out this video on how gamma ray burst could change everything. Thank you for watching.